do that. Okay, we're going to look at these formulas, and we're going to write it down, the formulas. Okay. This is not selected. Okay, all right. So sec theta is 1 over cos theta, and then cosec theta is 1 over sine theta, and then cot theta is 1 over tan theta. All right, write them down. Yep. Okay, ratio identities. Tan theta is sine theta over cos theta. That will be useful later on. And then cot theta is cos theta over sine theta. Right, that's done. Complementary identities. Sine pi over 2. So remember, pi over 2 is 90. So 90 minus theta. The complement equal to cos theta. Okay. So cos theta. So the one before it looks like this. So you get sine 90 minus theta. Oops. Maybe not good idea. Okay, so before you know a formula, sine 90 minus theta is cos theta. We're now going to write it in radian form. Okay. All right. So we do the next bit. Cos. This one will be sine theta. Tan will be cot theta. So just remember, cot and tan are related, and sine and cos are related, and sec and cosec are related. So that's equal to tan theta. That's equal to cosec theta, sec theta, and that will be sec theta. Right, done. So these formulas needs to be well known. And then we'll look at the Pythagorean identities. All right, Pythagorean identities, sine squared theta plus cos squared theta is equal to 1. And then you can write two versions of this from this formula, which is making cos squared theta the subject. So you get cos squared theta. This one you get sine squared theta. You should memorize them as separate formulas. Cos squared theta, cos squared theta. Okay, good. And so, okay, let's continue. 1 plus tan squared theta is sec squared theta. This is cosec squared theta. Just remember the co math with the co. Alright, so these are the Pythagorean identities. And then lastly is the quadrant identities. And these are not hard to learn. So what does the pi minus theta mean? So think about it in terms of quadrants. So pi minus theta, if that's theta, that's pi minus theta. So it's in the second quadrant. So if it's in the second quadrant, it's equal to sine theta, positive sine theta, but negative cos theta, negative tan theta. Yeah. And then the other one, pi plus theta, will be in the third quadrant, because that's pi, which is 180, plus theta, pi plus theta. So you get in the third quadrant, sine is negative. And the next one will be cos theta, will be negative cos theta, negative for cos in the third quadrant, but positive for tan in the fourth quadrant, in the third quadrant. And then we can do this. This one is in the fourth quadrant, because 2 pi is 360. Go back to theta, so that will be in the fourth. And then you can do sine 2 pi minus theta will be, will be cos. No, it will be sine, will be negative sine theta. Okay? Negative sine theta. Next one is positive cos theta, and then negative tan theta. Alright, like that. Let me draw a diagram. That's just 2 pi minus theta. Okay, good. And then if it's a negative angle, you go clockwise. You go that way. That's negative angle, negative theta. So it will be in the fourth quadrant, negative sine theta, positive cos theta, but negative tan theta. Yeah, so these are the formulas. Now, these two actually indicate what type of function are these two? What does that indicate to you? Sine negative theta is negative sine theta. What type of function? Anyone? Again? Even no, there's a negative there. It's odd. So remember, f negative x equals to negative fx. That means it's odd. Alright? And how about cos theta? This is a even function. So that's odd. Alright? Okay, so that will be useful later on. Now, another way to see this, you can also use the compound angle formula. See, you can also prove it in a different way, which is longer. So we do this one, sine pi plus theta. You can use the compound angle formula, which becomes sine pi, that you learn in extension 1, cos theta plus cos pi sine theta. What's sine pi equal to? Sine 180 is 0. Cos theta plus cos pi is -1 sine theta. So you get negative sine theta as expected. Okay, or you can think of it in terms of quadrant. That will be quicker to do. Or you can use the extension 1 formula. 3u. And the next page, we're going to go through some extension 1 formula. Okay, before we do that, let's quickly look at the reference sheets. How many of these are actually on the reference sheet? There's only these 3, these 4 given, and 5. There's only 5 formulas on the reference sheet. That's all. Just 5 of the identities just looked at. Everything else is not given. So basically, if you look at the all the information, only this one's given, this one's given, this one, and this one. That's it. That's all they give you. So you have to memorize all the rest. Okay. All right, let's move on. So we're going to go to the next page to do some extension 1 identities. See if you remember these ones, but always check the reference sheet to help you. All right, fill this out. Okay, let's try that. So sine A plus B, so I just go sine A cos B. So remember the pattern, sine cos plus cos, then sine. Notice that the position of A don't change. A goes first again, but the sine and cos gets switched over, right? All right, that's it. Okay, good. And what if it's a minus? You just have to change the middle term to a minus. So you still do sine A cos B, but cos A sine B. I have a minus. So the two formulas are quite similar. Okay. How about the next one? Cos. Cos goes like this. There's 2 cos's, but they do opposite. The plus becomes a minus. Sine A sine B. Like that. So cos goes double cos, then double sine, whereas the sine is sine and cos mixed together. Okay. Next one, same thing, cos A, cos B, but then plus sine A, sine B. Oops. Sine A, sine B. Like that. Alright, how about the next one? Next one will be tan. Tan will be tan A plus tan A plus tan B over 1 minus tan A tan B. Like that. And then the minus is tan A minus tan B over 1 plus tan A tan B. Now notice that for tan, the minus match with this minus here, whereas this one, the plus match with this plus. And for both formulas, the numerator is plus, the denominator is minus. If the numerator is minus, the denominator is plus. So it goes like that. Okay, these are the formulas. So we're going to, so you need to memorize them. That will be helpful in the exam. which is also on the formula sheet, but let's look at what part is given. So if you look at the extension one, they only give you the one with the plus. They only give you the plus one. They don't give you the minus. So if you have a minus, you just put a minus sign here. If it's a minus, you put a plus here. If it's a minus, you put a minus on top, plus at the bottom. Yeah. So, and they don't give you the double angle formula. So they only give you these three. And if you look at the one on the, go back here, they don't give you the double angle. So you have to memorize this. You have to memorize. Okay. Let's write them down. They are not hard to remember. So for sine 2 theta is 2 sine theta cos theta. Okay. So you see the double angle formula for sine is very similar to this compound angle for sine because it has a mixture of sine and cos. Sine and cos. Now cos 2 theta, it looks very similar to this formula. A plus B, cos cos, sine sine. So you get cos square when they are the same angle minus sine square theta. Alright, like that. Now for the double angle for cos, there's two other versions you have to memorize. Not just this one. There's another two which will be useful in other contexts. Let's go through them. So cos square theta minus sine square theta. And there's also 2 cos square theta minus 1 or 1 minus 2 sine square theta. So sometimes better to just write cos 2 theta in terms of cos only. Sometimes write it in terms of sine only. Sometimes you do a mixture of both. So there's 3 versions you should memorize. Whereas this one, there's only 1 version. Okay. Alright, next one. Tan 2 theta is very similar to this. You just add them together, you get 2 tan theta. See the 2 tan on the top, you add them together. Over 1 minus, when you times them together, tan theta times tan theta, you get tan square theta. Okay, done. These are the formulas, but unfortunately it's not on the formula sheet. I presume that you can just derive it from the exam, but it's better to memorize them. Alright, we've got the double angle formula. Fortunately, they do give you the T formulas, which is these, T substitution. So that's given to you, but it's good to memorize them as well. Let's write them down. 2t over 1 minus t squared. This one is 1 minus t squared over 1 plus t squared. And this one is 2t over 1 plus t squared. Okay, like that. Now, they all look a little bit similar because the denominator looks similar. One way to distinguish between them is that, remember tan theta has an asymptote, right? It has asymptote for tan. So just remember this can be 0. There's a vertical asymptote. Whereas this one, it can never be 0 because sine and cos doesn't have vertical asymptote. That's how I remember that has a plus, this has a minus, due to the fact that the tan graph has an asymptote. Okay, see, if you put 1 there, you get 0 in the denominator. So you get a vertical asymptote. Okay? Alright, so let's get rid of that, Okay, good. Alright. What else are there? Auxiliary angle formula. That's not on the formula sheet, so let's write them down. So what's the use of this? You can write it in the form of r sine theta plus alpha. Okay? And this one you can write it as r sine theta minus alpha. If you start with cos, you write equal to r cos theta, but if it's a minus, you write plus alpha. Note the difference. Asterisk key. Just be careful. And the other one is equal to r cos theta minus alpha. In all 4 instances, there's a formula for r equal to the square root of a squared plus b squared. And to calculate alpha, you just do tan inverse of b over a. Auxiliary angle formula. That's useful when you have a sum of 2 terms, sine and cos, or cos and sine. Okay, which you can turn it into 1 term, which can have applications in solving trigonometry equations as well as curve sketching. Okay, and the last bit we have is general solution. That's on the formula sheet, so let's write them down. It's n pi plus minus 1 to the power n times by sine inverse of A. Okay. So what's n? Where n is an integer. Any integer. Could be positive or negative. Right, how about the next bit? Next bit, tan theta is very similar to sine, except it doesn't have this extra. You just go tan inverse of A. And the last bit is n pi, 2n pi, but you go plus or minus cos inverse of A. Let's write that again, 2n pi. Okay, these are all the extension formula you need to know for trigonometry. Now let's look quickly back on the reference sheet. So where do I get that from? Can't see it. There it is. Oh, here. They put it all together. Okay. Okay, good. That's it. Okay, good. All right. So we'll go back to wrong one. This one. Okay. All right. So these are all the extension 1 formula. Now we're going to do some examples together and apply these formulas. Okay. So just recap that only some of them are on the formula sheet. The one on the formula sheet is only going to be the t substitution, as well as these 3, and the general solution. That's all. Everything else you have to memorize. These one you have to memorize. Okay. All right. Okay, good. All done. Let's move on to the next question. Further trigonometry. We're going to do some examples together. Then we'll try the exercise. Just one exercise today, 5.2. Okay, expand and simplify. Very easy. Use the compound angle formula. So you can just look at the reference sheet. So remember, just write it down. Cos A cos B minus sine A sine B. Okay, so what do? We're going to write equal to cos theta cos pi on 6 minus sine theta sine pi on 6. Like that. And then you have to simplify it. What's cos pi over 6 equal to? Exact form. Cos pi on 6 is root 3 on 2. Good. Sine pi over 6 is 1 on 2. Yeah. So you get, what do we get at the end? So you get half. You get root 3 over 2. Better to write the number in front of the pronumeral minus half sine theta. Good. Okay. All right, good. So we can do this sort of questions, which will be in your textbook. And then there's other question we can find. All right, let's do that. Let's do the next one. Simplify this. So you make a common denominator. So you go 4 pi over 12 plus 3 pi over 12, which is 7 pi on 12. Okay. And this is related to part B. Okay, so let's go to this bit. Okay, now how do I use it to do part B? So to work out the sine of this, the exact value, which is 7 pi on 12, what you need to do is to write equal to sine. Now what's 7 pi on 12 is the sum of these 2 angles. And these 2 angles, we know their special value. That's why we want to write it in this way. Oops, pi on 4. And then why do I do it this way? So I could use this compound angle, this formula, or the other one. Okay, use the compound angle to expand. So you write sine pi on 3, cos pi on 4, sine and cos, and then plus cos pi on 3 and sine pi over 4. Like that. And then you have to think about the special values that you found. What's sine pi over 3? What's cos pi over 4? Etc. And then simplify your answer. Okay, let's continue. What do we have here? Sine pi over 3 is root 3 over 2 times by 1 on root 2. So you should try to memorize them. If you haven't, please do so. It will help you. As you can see in this situation, it makes it very easy. Cos pi over 3 is half times 1 on root 2, like that. And you have to simplify. You get root 3 over 2 root 2 plus 1 plus 2 root 2. And then your final answer will be root 3 plus 1 over, they have the same denominator. All done. Okay, so this equal to, that's the exact value of sine 7 pi on 12. Yeah. Maybe not. I think it's okay. All right, but we can rationalize just for practice. So you get root 2, root 2. What do we get? We get root 6 plus root 2 over 4. Yeah. Now, how do I check your answer? How do you know if your answer is right? Now, to check your answer, use your calculator. What you do is you go shift sign. Let's do, or you can do in degree mode. So shift sign root 6. You can type in fraction. Root 6 plus root 2 over 4. Alright, give you that. 75 degrees. That's 7 pi over 12 times by pi over 180. Or divide by 180. Yep. Oh, 5 over 7, 12. Made a mistake there. How can that be? Yep. Oh, yeah. Excellent. Very nice. Very good. Very good. Yes, this is second quadrant. That must be the related angle. Oh, amazing. That's good. All right. Okay. All right. So it's hard to check your answer, so I was wrong. Okay. All right. So let's do example 13. Example 13. All right. Cos 2x equal to cos x. So when you have a different angle, change that to a single angle. So you have to use the formula. Now, how do I use the formula? There are 3 versions. Which version do you use? There's the cos x squared x minus sine squared x, 2 cos squared x minus 1, or 1 minus 2 sine squared x. Which one will be good to convert to, and why? Yep, Mitchell? Yeah, because they are the same, right? You don't want to use a different symbol, right? So you change that to 2 cos squared x minus 1 equal to cos x, like that. And then move all terms to the left side. And then you get a quadratic equation. So you just have to let u equal to cos x and then solve. Alright, solve for u. Okay, have a try. And then once you find u, find x by solving a trig equation. Okay, have a go. So you can solve it by using quadratic formula or by factorizing. Up to you what to do. Okay, let's try to factorize 2u minus 1 plus 1. Hopefully you got that. U is negative half or 1, isn't it? Okay, now you have to find x. So you have to go back to cos x equal to negative half or cos x equal to 1. So for the first one, you have to look at quadrant, negative in the second and the third quadrant. What's the related angle? You find the related angle by doing related equal to cos inverse of positive half. And if you know your exact value, that's 60 degrees, which is pi over 3. So write pi over 3 there, pi over 3 there. Right? And then you can find x. Remember we solved trigonometric equations yesterday? Hopefully that they are easy for you now after doing all the practice. So x will be equal to pi plus the related pi minus pi over 3, comma pi plus pi over 3. So it will be 2 pi over 3 or 4 pi over 3. Like that. And what do I do when it's cos x equal to 1? What method do we use? Graph. Yes. Do not use the quadrant. So let's draw this. Because I did when it's a 1 at 0, add 2 pi. Done. So you have 4 solutions altogether. Alright, so like that. Yeah, you can just, no, if you just write this down, it's okay. Yeah, but the graph will help you to realize there's another number 2 pi. Okay, last bit is general solution. It's very easy. You just have to apply the formula. Let's write down the formula. Theta is n pi plus negative 1 to the power n sine inverse of a. So for this one, you have to say this is sine theta equal to half, isn't it? So applying this formula means that the general solution is theta equal n pi plus negative 1 to the power n sine inverse of half. Oops. Half. Now what's sine inverse of half? It's pi over 6. So you just leave it in terms of pi and n. And then you should write a statement, what is n, where n is an integer. So we know what n is. Alright, done. Alright, general solution. So general solution pretty easy. You just have to use the formula. And it's given on the reference sheet. You don't have to memorize it, but if you memorize it, that's also okay. Good, so today you just do exercise 5.2. Now 5.2, we've already started last lesson. So you only have to do, starting here, just these ones. Start from question 13. Oops. Start from question 13, yep. Yeah, and then continue. All right, yep. Oh, great.
So if you have a look, it has
yep.
curve sketching,